Hi, Professor. My name is Manuel Sanchez, and today I'm going to demonstrate my favorite concept from this semester in physics, the universal law of gravity. Specifically, acceleration and the idea that all objects near the Earth's surface fall with the same constant acceleration regardless of their mass. Now, this acceleration we know is approximately 9.8 meters per second squared, meaning that every second an object is in free fall, its speed increases by about 9.8 meters per second. Now, no matter whether this object is a bowling ball, a tennis ball, or a piece of paper, it will fall with that same speed. Now, this concept was developed by Isaac Newton. He developed the universal law of gravitation, and the key concept of his law of gravitation is the acceleration of a falling object is independent of its mass. Now, to show this in action here, I'll be performing four experiments, and each one is going to highlight a different part of how gravity works. And together, they show why mass doesn't change gravitational acceleration and how air resistance sometimes can make it look like it does. So for my first experiment, I have two objects with noticeably different masses, one heavy and one lighter. Now, according to intuition, most people would think that the heavier object is going to fall faster, but according to physics, as long as there's no air resistance, both will accelerate at the same speed. Okay, now when you see when I drop them, both objects experience the same acceleration. The heavier object does have a stronger gravitational force. Yes, that part is true. But it also has more inertia, meaning it's harder for it to accelerate. And as those two effects cancel each other out, more mass gives more gravitational pull, but more mass also brings more resistance to that acceleration, meaning they fall at the exact same speed. Now, as you saw, they hit the ground same time, or extremely close. That's because the gravitational acceleration does not depend on how heavy something is. Again, this experiment directly demonstrates the principle that all objects fall with the same acceleration in free fall. So for my second experiment, I will take two objects of equal mass, and this time I will drop one straight down, and I will toss the other one forward horizontally, just so slightly. Hopefully this stays in camera. So even though one object had a sideways motion, gravity still acts downward only, or towards the center of the Earth. Tossing something forward doesn't change the way it accelerates vertically. Now, horizontal motion and vertical motion are completely independent. So we see when you toss an object forward, you only give it the horizontal velocity. You don't give it the extra hang time. Gravity still pulls both objects downward with the exact same acceleration. Now, if you watch carefully, you see that both objects hit the ground at the same time, or extremely close again. The tossed object traveled farther horizontally, but its downward motion matches the dropped object perfectly. So even though their paths look different, the vertical acceleration was identical. Of course, the mass is the same, but this reinforces the principle that gravity pulls all the objects down in the same way, regardless of whether it's moving sideways or not. So for my last experiment, it's kind of a two-parter. I'm going to take a piece of paper and a book, and this is to show air resistance and how it does matter, but it makes it look as if the gravitational pull is different based on mass, which it isn't. So when I drop them together, the book will fall quickly and the paper will drift down slowly. Now again, like I said, this may seem like gravity is weaker on the paper, but that's not what's happening. Gravity is pulling both objects downward with the same acceleration, but the paper experiences much stronger opposing force, which is air resistance. And air resistance pushes the paper and reduces its acceleration, and the book being heavier and having a smaller air catching surface is barely effective. So I will drop them. Now, I'm going to place this paper directly on top of the book. What this does is it removes all of the air resistance acting on the paper because the book pushes the air out of the way for it. Now, as you can see, they fall together and hit the ground at the exact same time. That's because we removed the one thing that was causing them to fall differently, air resistance. The gravitational acceleration on both objects was always the same. It's just that the paper was being slowed down by the air. Now, in all three of these demonstrations, we've seen the same conclusion. Gravity provides the same downward acceleration to all objects near Earth's surface, regardless of mass, shape, or motion. A heavier object has more gravitational force acting on it, but it also has more inertia, which resists acceleration. A lighter object also has less force, but also has less inertia. Those two quantities cancel out, leaving them with the same acceleration for everything. So whether an object is dropped, thrown sideways, or resting on top of another object, the same rule holds true. Gravity accelerates all objects by 9.8 meters per second squared. And this is the universal law of gravity and the foundational idea behind almost all motion near the Earth's surface. Thank you.